Hi everyone. The lead code question for 1 July is to find the safest path in a grid. So I have a grid in which empty cells are represented by 0 and non-empty cells are represented by 1. So non-empty cell is basically 1 means there is a thief there. So we have to calculate the safest path that we could get from our start to our destination, and the safeness path is basically minimum distance from any cell in the path to any thief in the grid, and we have to maximize the minimum safeness path. Okay, so we are going to solve this using multi-step BFS and modified Dijkastra. So let's see how do we do it. So we'll solve it one step at a time. So let's say we first want to build we want to build a distance grid. So let's write multi-source BFS. So multi-source BFS, it will give me an integer array. And then in here, let's say I have this distance array, which basically we call multi-source BFS. Multi-source BFS on this grid. So let's also pass, so its grid is n to n. So let's say n is equal to grid dot length, grid dot size. Since it's an array list, right? So then let's also pass n, and yeah. So what is this? This will basically give me a distance matrix. What is this distance matrix? It basically means the distance from of a current row and column from a thief. So let's say we initialize this uint with a value n comma n. Since for every cell we need a distance. Then now what we do is we first will initialize my array with minus ones so that we don't have to keep a track of the visited or the cells visited in a separate data structure. So let's say we call this the row in this. So we fill this with minus one since it's a 2D array, right? Okay. Now whenever we encounter a thief, the value will be 1. So wherever the value is 1, let's say our distance matrix will be 0 there, because the minimum distance would be 0 from a thief to the thief itself. So we are traversing the array, and wherever we encounter a thief, we'll just mark that cell with the value 0, since the distance would be 0. How do we know it's a thief? If the grid value is equal to 1. Now I have to write distance of that particular ij row and column from the nearest thief is 0. Okay. Now we need to calculate the minimum distance of the thief from various, for all the remaining cells. So for that, we know that, we can move 4 ways: up, down, left, right. So let's say our the row would be moving by 0, 0, 1, -1. Then let's say I have this G column, like the change in row and column. So that will be 1, -1, 0, 0. So this is how we can go 4 ways. So in the queue, since we're doing this multi-source BFS, we should have a queue. So let's say we have this queue, which will store the row and column. And let's write this as queue is equal to new list. So now we are going to add this to the queue. So now my queue will have I and j value. So what I'll do is until my queue is empty, we are going to go through the while loop. And in the end, what do we need to return? The distance matrix. Okay, so now let's pop when the queue is empty. So I will get. So when my queue is empty, we'll get a current index from the queue. So let's poll. So when I poll, let's say my current distance would be current of um current of row and column. Okay, so let's do row is current of 0 and column is current of 1. So these are my current row and column. Okay, now what we do is we have to move 4 directionally, right? So now how do we move 4 directionally? We are going to use a loop, I less than 4. Since we're starting from 1, so I is less than equal to 4, but let's start it from 0 so that indexing is easier. And then have I plus plus. Now what we're going to do is, yeah, so my new array, a new row will be int. New row will be row plus new row of I, and my new column will be column plus new row, a new column of I. Not new row, change in row and change in column. Now we'll check if this is in bounds. So if nr is greater than equal to 0 and nr new row is less than n, and new column again, we're checking, sanity check if the index is in bounds. So if this is there, it means our index is in bounds. And then we also check if this is visited or not. So if my distance of new row and new column is equal to -1, it means that is currently unvisited. So in that case, our distance of new row and new column would be distance of parent. How do we get the distance of parent? Row and column plus 1. So we do this here, and yeah, this is how we calculate. And then what we do is we also add it to the queue. So now queue will have offer what new int nr and nc. So this is how we do it, and yeah. So this was how my distance array is calculated. Now, since we've calculated the distance array, now we'll use this modified Dijkastra to find, you know, maximum safe path possible. So let's use a max heap here. So my priority queue will store three values in an integer array format. So this is my max heap, and this will be new priority queue, and we are going to sort the priority based on the safeness. So that basically means we are going to give it a comparator. So let's say we have A comma B. So whichever has the maximum safeness should go first. So this is how we do it. Now I'll tell what does maximum safeness mean. Now let's also have a visited array. Let's say of Boolean data of n cross n. So we'll have a track of if that current cell has been visited or not. So this is what we do here. And then let's first add something to the queue. What do we add? We are going to add the starting point, which is a 0, 0. So now my max heap dot add has I have to add three things. 0, comma 0 is my row and column. I have to add the safeness factor of the cell. So what will be the safeness factor of the cell? It will be the distance of 0, 0, right? That's the safeness factor of the first cell. Now, until my max heap is, empty, so we're going to traverse, we're going to see if we have a path. And in the end, if we find no path, we're simply going to return 0 since there is no maximum path available. So let's say we have we need to check the maximum path seen so far, right? So the maximum path seen so far is, let's say we have an integer variable, int max path seen so far is will be given by maxheap. Let's not store it here. So let's say I'm going to currently poll. So let's say int current is equal to maxheap dot poll. Now what will it give me? Initially it will give me this value, like wherever, let's say I have it's going to give me 0, 0 and the distance from the nearest thief, the distance here. Now what I need to do is my current safeness is what? Current safety is current of 0, and my current row is current of 1, and my current column is current of 2, right? Now what do I need to do? I need to find the next path available. So since we have polled this, so let's also now say I have visited row and column. So now I'll mark this as true. Now before marking this, let's first check if we have already visited this row and column. So if visited of row and column is true, so it means we've already visited. We don't need to do anything. Let's just continue. Else we'll mark that cell as visited. Now, what I need to do is we will have, let's say, 4 ways or 2 ways, whatever. Let's say if I'm here and my max heap says like this is the current safety I have. And let's say I have how many options from this row and column do I have? I can either move down or I can move right. Right? So those are the possible So this was for calculating the distance, and we can move to any adjacent cells in the grid. So again, the same thing, we are going to have this, so we can move to adjacent cells, right? So then we have this. Now what do we do is, now since this is actually used in two places, let's have it here, and let's pass dr and dc, and let's have integer dr and dc, and remove it from here so that there's no code duplication. Okay, now what do we do is, since we already have that, okay, now let's move in four directions. We have four possible values now, that's why. Now I have to, let's say for this, I have first I'll check if this is a valid row and a valid index. So now my new row value is row plus d- change in row of I, right? Change in row of I. Yeah, this. So let's copy paste it here. So these are my new row and new column. Now let's do a sanity check. If new row is greater than, well, let's copy paste it from here. So we do a sanity check, and we also check if we're not going to check if it is visited here. The reason being, we are going to we are checking already if it is visited or not, right? So then what do we do is we say ki, so now my current safety will be, now let's calculate my current safety. So now my new safety is the minimum, this minimum of current safety, current safe path seen so far. So it will be current safety, minimum of current safety, and the safety for this new cell. So what is the safety for this new cell? It will be distance of NR and NC, right? And then we are going to add it current safety to this maxi. Okay. Now this is what we do. And yeah, so then we always keep a track of whatever is, the maximum value. I'll tell why. But first, let's check if my NR, if my row and column, if my row is equal to n minus 1, and my column is equal to n minus 1, it means we have reached a destination. So then we return current safety. So the reason we are using this queue max heap is that, let's say I am standing at any cell, and let's say I'm standing here at 1. So 1 has some safety. I can move down and I can move right. So what will be the safety of this path? So the safety will be minimum safety seen so far. So that is what we are doing here, math.min of current safety and this. Now, the safety for this path will be minimum of the distance values or the safety value, right? So that is what we have done here. So then we add the new safety, not current safety, the new safety for that particular row and column. And then our max heap will always give the maximum safety element first. So, safety can always decrease or remain the same, but it will never increase since we are using math.min. Now it will give me the if let's say I have a safety value 5, and let's say I have another safety value which is 4. Now my heap will always give me 5 first. Since if I explore this path first, then there are more chances of me getting the maximum value first. So that is why. So let's see if our code runs. So no, it doesn't run. My output is -1 and the expected is 0. Why is this -1? Let's ask Gemini. Yeah, so there was a minor bug. I kind of saw this. Here we have used NR and NR twice, so that is why we were getting the error. Let's resume. Now we have TLE. Okay, we are running into an infinite loop. So here let's give it visited of NR and NC, and it is not visited. So only then we will again process it. Let's see what's the error. Yeah, so the error is basically I have again did the same mistake here. I've written NR twice. So let's see if we have done that here also. NR and C. It is correct here. Okay, now running it again. Yeah, now the test cases have passed. And yeah, the solution is accepted. So our time complexity for this is n square log n. So yeah, this is it. And the space complexity would be we are we can at max have all the values. So big O of n square if n is the number of rows. So yeah, that was it from my thank you.